Okay, just going to go over a couple things here with your virtual lab that you are working on today. So what we're going to do is we're going to explore the law of conservation of momentum, and we're going to use the collision cards from the physics classroom. You can get to the link by clicking in the click here button or click on the title of the lab, and it will look like a picture like this. When I open up and click on that web page, if I scroll down, you'll see the interactive located right here. You will also need this might become in handy, this little triangle down here in the corner. If I click on it and I move the button, I can make this larger or smaller. That way I don't have to scroll up or scroll down. But that is a very handy button. It's just making that so that it fits on one page. If you come over to the lab, if you read the directions, those are the things that tell you what to do, kids. But it'll tell you what you're supposed to do. You're supposed to calculate the momentum of each cart before the collision using the equation P equals mass times velocity. Hit the start button at the top right corner of the animation. Record the after, mass, and velocity for each cart. Mass should not change, but the velocities will. Calculate the momentum of each cart after using, again, P equals mv. Calculate the total momentum before and after by adding the momentum of both carts together, and then repeat this for the remaining trials. So, again, if I am looking at trying to determine what is the momentum of the red car, what is P? P is m times v. So 1 times 5 is 5. If I'm going to find the momentum of the blue car before, again, momentum is m times v. So 1 times 0 equals 0. To find the total momentum, I add the momentum from the red car, this one right here, to the momentum of this car, which is right here. So 5 plus 0 equals 5. Now over here for the after, mass doesn't change. So the mass of cars is 1 for the red, it is 1 for the blue, but our velocities will. So in this particular trial, I want an elastic collision. I want both to be a mass of 1 kilogram. I want to click start. The blue car ended up having 5 meters per second. The red car ends up having 0. Back over to the lab. This was 0. This was 5. Calculating the momentum after. Mass of the red car is 5 times 0, which would be 0. 1 times 5, which is 5. And then I'm going to add the red car, 0, plus the momentum of the blue car, and that is also going to equal 5 for the total momentum. Trial 2, I'm still going elastic. I want another, but this time I want a 2 kilogram. I click the reset button. I want to increase the mass to 2 kilograms. Still starting out with 5 meters per second. I click start. This time, since this cart goes backwards, please note what is in front of the 1.7. It is a negative sign. That negative sign tells me the direction, negative 1.7. This one over here is 3.3. The masses do not change. The mass of the red car was 1. The mass of the blue car is 2. So when I find the momentum of the red car before, that is 5 times 1, which is 5. That is 2 times 0, which is 0. The momentum of the red is 5 plus 0, which is equal to 5. Over here, same thing. I have 1 times negative 1.7. That gives me negative 1.7. Oops, wrong button. Negative 1.7. I take m times the VF, 2 times 3.3. That gives me 6.6. And then I want negative 1.7. I'm adding that to 6.6. And that is going to give me a momentum 1.7 negative plus 6.6 equals 4.9, and that is the momentum of the total momentum after. Okay, but that's how you go through and do the lab. You have one more elastic collision. In order to change over to inelastic, you just click, after resetting, you click this button for inelastic, or if you're doing the explosion, that is the recoil interaction, that is this button. But that's all the more there is to the lab. Good luck.